Hello and welcome to my videos, and we are discussing cryptography concepts and modern day algorithms that we are supposed to use in our um, all applications which are where we are concerned about security. So we already discussed about Farnet symmetric encryption in from this cryptography module or this library. Now we are going to discuss about this authenticated encryption, and there are multiple algorithms, so we are just going to check a couple of algorithms. So what exactly is authenticated encryption? Authenticated encryption with associated data. This encryption scheme provides both confidentiality and integrity for the ciphertext. So far in Fernet symmetric this example, what we saw, we created key and we encrypted that key. But what if data is forged by intruder? So we won't be able to understand, we won't be able to know if that has happened. So for that, the algorithm that we use is HMAC, right? Or MAC or message digest or checksum is used to check if it is called as message authenticated code. So here what happens is, along with encryption, we are also providing authorization through this MAC algorithm, that is message authenticated code. So in simple words, we are doing encryption as well as we are creating hash of that original message using this password, using one password. Okay. So let's look at how it looks like. So I have copy pasted this code. I will explain here. So this is ChaCha20 Poly 1305. So it is combination of two protocols. So ChaCha20 is a encryption protocol and Poly 1305 is message authenticated code, and this combination provides a very strong way of protecting your information. So just like Fernet, we generate a key, then this key is passed to a constructor, and the output is object on which we can use encrypt function. Now here we should be look at the parameter for both encrypt and decrypt operation. We need, apart from data input, we need nonce and AAD. So nonce is a randomly generated data, a number used only once. This is a number, random number. It is used only once, often employed in a cryptography protocol to prevent a replay attack. So actually speaking, this number is a time bound and it has very short life. So this both in previous example in Fortinet, we use salt, right? Salt has a different salt is also generated randomly, but nonce is a number which is used to avoid replay attack. So suppose we have intruder is not trying to decrypt the package, but instead of that, it is storing that package and it is going to replay that. It is again going to reset that packet after some time. That is called as replay attack. Okay, and this replay attack, to avoid this nonce is used, and this AAD is actually a password. So it is used for the output of this encryption, this CT. If I print, so it's a byte output, right? So this CT has both encrypted information, encrypted data plus authenticated data. So this algorithm is also very easy to use, and you just have to add these nonce and AAD. Okay, so this is how you will be using this protocol. The second implementation is AES GCM. Here we have option to generate key. Let me copy paste and I will explain. So here if I print, it should print original message, secret message, right? So again, here we have data, that is secret message. Then we have password similar to Chacha-Pauly algorithm. Then here we have key, which is output. And here you can see some interesting thing, that here I can actually pass 256, which makes this algorithm very stronger. It generates key of size that much bit length, the parameter we provide. So it can generate 128, 192, 256. And as I mentioned, we need 256 bit of key. So this is key, AES-GCM, same. We create object, pass the key. Then here also we use nonce and AAD as parameter along with data. So very similar to what we have seen in AEAD. Okay, we have few more algorithms, AES GCM IP. Full form of GCM is Galois counter mode. If you want to use initialization vector, okay, synthetic initialization vector. So what is initialization vector. So suppose if you are generating secret, right? So while generating secret, if you want to use some salt, we use some salt, right? So similarly, you can use some random values. Instead of one value, you can use few more random values, more than one random value, and it is known as vector. Here you can see data AD key, and here IV. So actually speaking, here this IV is not provided, although the code looks very same. We are passing key, creating nonce CT. Actually speaking, it looks very similar. And if I go on and check another few more examples, okay. So AES SIV, in this version, we also have 512 bit key we can create. So this seems very strong algorithm implementation. And here also, I think it creates this IV internally. Yes, IV, and yeah, data and AD, that's it. So random nonce should have at least 128 bit of entropy. If nonce is reused, the SIV or retain confidentiality. So we have to reuse this nonce, and confidentiality is only compromised to the extent that attacker can determine the same plain text. All right. So this was about AED, very strong algorithm. This was about authenticated encryption. So in next video, we will be talking about ECC or elliptical curve cryptography. Thanks for watching my video.